Mid-segments of triangles. Here's what you need to know, okay? In a triangle, it's my turn now. If you have this setup, a mid-segment, think about what that sounds like, right? Middle, segment is a segment. So it's a segment that joins the midpoints of two sides. So if I took a midpoint over here, where these two are congruent, and I took a midpoint over here, where these two are congruent, the mid-segment is the segment that joins those two midpoints. So let's change the color here. The red is my mid-segment. Okay, so how many mid-segments can a triangle have then? Three. You're going to have 3 different mid-segments available. Now, that doesn't mean they'll all 3 be there, but you could have 3 different mid-segments in a triangle. So there's a theorem. It's called the triangle mid-segment theorem that goes along with this. One of them talks about the length, and one talks about more the orientation of this line. So I want to see if any of you can guess what might be true about that red line in this triangle. Either something about the length of it, how it relates to the triangle, or its orientation. Anyone think you have an idea what could be true about it? Parallel. Okay, that's the first thing. So in the triangle mid-segment theorem, basically what it says is the mid-segment will be parallel to the side that it's not in contact with, right? So the first thing is these two lines will be parallel, okay? Any guesses what might be true about the length of it? How it relates to any part of that triangle? It's totally a guess. You're allowed to make guesses that are wrong. It's half of the bottom one, okay? So if this is x, then this is going to be 2x, right? Or you could say if the bottom one is x, then the mid-segment's going to be 1/2 x. Okay, so those are the 2 things that the triangle mid-segment theorem says. I'm not going to write that out because I showed it to you in picture form, but that picture is showing you the details of it. Okay, they will be parallel to the opposite side, and the mid-segment will always be half as long as its opposite, the side across from it. Okay. So first thing you got to be able to identify are what are those sides that are parallel. So this is example 1. Let's say I give you this triangle. Okay, if I do a midpoint here, a midpoint here, and a midpoint here, that gives me a mid-segment, a mid-segment, and a mid-segment. Okay, so we have 3 sets of parallel lines right now. If we name this A, B, C, and D, E, and F, okay? With this as our setup, I want to know which segments are going to be parallel. So what is parallel to DE? DE would be parallel to CB, or you could call it CF or FB, yeah. But we're going to just call it the whole segment for now. Give me another pair of parallel lines.
CA and FE.
CA is parallel to FE, and there's one more.
DF and AB.
DF and AB. So Bryce has it. Do the rest of you have it? You good? Okay, so you're just looking for the parallel lines because those parallel lines then are going to tell you which one is half as much as the other and vice versa. So if you can identify which ones are parallel, you can identify which ones have a relationship in the problem. Okay, here's where the relationship comes in. Example 2. You're pretty much going to draw that same type of picture, but I'm going to make it look a little bit different this time, not terribly. So if this is triangle EFG, okay, and then I give you a midpoint here, a midpoint here, and a midpoint here. Okay. They're going to tell you some information, not all the information, but they're going to tell you enough that you can find the other pieces of information that you need. So what we're going to do, we're going to say this side here, FE, has a length of 60. Okay, we're going to call this point H now. We're going to call this point J, and they're going to tell us that HK, this is K down here, has a length of 40. Okay, and then the last thing they're going to tell us is that EG has a length of 100. Okay, so this is your picture. We have to figure out the missing lengths. So I want to know how long is FG, how long is HJ, and how long is, what's my other one, KJ? Okay, so those are the three missing segments right now. Those are the three segments we don't have lengths for. Where you need to be careful is what is the relationship. So the one that's the outside of the triangle is the bigger one, right? The ones that's inside with the mid-segment, those are the ones that are going to be cut in half. So if I know right now, let's see, FG corresponds to which other segment? HK. How long is HK? It's 40. So if I know this is 40, then what is FG? 80, okay? And you have to be really careful here because I know you don't think that 20 makes sense, but a lot of times people will tell me 20 there because they're so used to cutting things in half, okay? But that one you're doubling. So you're just taking the 40 and you're multiplying it by 2. That's a 4. So that means that FG has a length of 80, okay? What would the length of HJ be? Benjamin? 50, right? You have this side across from it. The corresponding side is 100. You're cutting that in half because it's the mid-segment. So half of 100 makes it 50. Okay, and then last one, what's KJ gonna be? Connor? 30. That would be 30. So you have this side over here is 60. This JK or KJ has to be half of it, so half of 60 is 30. Okay, questions on that? Okay, then what do you do with this? Same idea, but slightly different setup. If these are congruent and those are congruent, and I tell you this has a length of x minus 1, and this has a length of 52. Okay, now you have an expression. It's not just numbers there, there's an expression there. You have two options. You can either cut something in half or you can double something. They both work. They both will get you the same answer. What you should not do is cut the one in half and double the other, because then you're reversing what you just did, right? So either double the one or cut the other in half. Take your pick. What would you like to do? And I can show you both, but what makes the most sense to you right now? Does it make more sense to cut a number in half or to double something? Cut it in half. I like cut it in half on this one. The only reason I like cut it in half on this one is because if I double my x minus 1, what do you have to make sure you do? It starts with a D. Distribute, right? So if I'm going to double x minus 1, I can set it equal to 52, but you have to make sure you distribute then, okay? Or what I like better is I'd rather just say x minus 1 equals half of 52, right? Because then all we have to do here is make that 26. So x minus 1 equals 26. You're going to add the 1. So x should be 27. Okay? I'm going to just show you that if we solved it the other way, you'd get the same thing. Okay? So if I did this, 2x minus 2, if we distribute it, equals 52, you're going to add that 2. So 54 equals 2x, and then you're going to divide by 2. So x is 27. So regardless, you're going to get the same answer, right? They both come out to 27. Just make sure that you don't do both. Don't cut the one in half and double the other, because those are not equal, okay? Questions on that? Okay. Last thing. I'm going to take you on a little journey. Are you ready?
No.
Do you like to go camping?
No.
We're going to go camping. I don't know if I wrote example 3 on that last one, did I? Yeah. Okay, so example 4 here. We're going to say you're going camping with your family to a lake, okay? But you're on the swim team, and your swim coach says if you do not swim X number of miles every day while you're on vacation, you're off the team. Okay? Off the team, can't do it. And you're an honest person, so of course you're going to do what your coach says. So there's a lake where you're going, and you need to figure out what's this going to look like. Oh, they're bringing stuff. So here's our lake. Okay, we got to figure out, in order to get the number of miles in that we want, we're going to swim across the lake. Okay, but there's no way to tell how far that is across the lake. We don't have a huge measuring device with us. The GPS out here doesn't work, so you can't just check it on your Apple Watch or whatever it is you have, okay? So instead, we got to figure out, how do I figure this out? Well, there's this beautiful open land all out here that you can walk, right? So let's say I decide, okay, I've got this plan. I'm going to walk from here 35 paces, and I'm going to put a peg in the ground. Okay? And then I think, oh, I got this. I know what to do. I'm going to walk 35 more paces to here. Okay? Somehow this is going to help me figure out how far it is across the lake. Anyone see where I'm going with it? What could I do next?
35.
What? Make a triangle, okay? So I'm going to walk over to the other side. Sorry, my triangle curved a little. I'm going to walk that off. But can I just walk halfway right now? Do I know what halfway is right now? It's not necessarily 35, right? Because it's a different side of the triangle. So we got to walk the whole way. So we walk that whole way, and we figure out that was 236 paces. How does that help me? What can I do from here? So I'm standing right here right now, right? I'm standing at the other side of the lake. Do you see what I can do next? What? Aaron? Not add 35. What am I trying to get here? What are we learning about in today's lesson? A what? A mid-segment, okay? So if I want to get a mid-segment, where do I need to walk to right now? You divide by 2, right? We're going to cut this 236 in half, and that's going to be 118 paces. So I need to walk back 118 paces. 118 here, which means this is 118 over here, right? Now what? You walk across the middle there, right? I'm going to walk from here across to my other, that was terrible. Try that again. Apparently I'm not in the middle. Across to my other point here. Okay, so however many paces that is, which it worked out to 128. Okay? I know that distance. How far is it across the lake? Not 128. Double it, right? That should be half as much. So to get across the lake, it would be 128 times 2. Oops. Or 256. Oh, swimming is important to this guy. So it's 256 paces. Okay, now technically we would say a pace, like if you're just a normal stride, is probably about how many feet? I guess it depends on your size. You'd have to evaluate based on your size. I would say average is probably about 3 feet for a stride. Okay, so if it's 256 paces and each step you take is about 3 feet, you would just do 256 times 3. Oh, which I already did. So it's about 768 feet across that lake. Okay, so if we had to figure out, I have to swim 2 miles, you could figure that out knowing that that's 768 feet. How many feet in a mile? 5,280, right? So you could work that out to figure out how many miles you would be going. Yeah, Noah. This 128, we walked it off, right? Once we walked back to this point, then we walked over to that initial peg that we put in the ground that cut it in half. So we walked all this off. We walked 35 feet, another 35 feet, then we walked 236, back 118 to here. Okay, and then when we get there, we walk over to the other point to measure how far that is. So it's all just, I mean, it's a rounded number, right? Because you're just, do you have a tape measure that's 768 feet long? Yeah, me too. Any questions on that? All right.